So let's discuss this question basically. So which says we are basically given one array, and after doing number of operations, or let's call it n number of operations, we need to figure out what is the maximum frequency that you can achieve for any element. Now, what is the operation actually? So y- to any element of this number, in each operation what you can do, you can basically uh, so suppose this is our number a, you can set this number anywhere between this, like if it is a, you can set it to a minus k or even a plus k, and in each of this operation I needs to be unique, or basically any number can be modified uh, only once, and we need to do the number of operations, uh, like basically we need to do n number of operation, and it's compulsory, like you cannot reduce it, reduce the value of n. You need to do exactly a number of operation, and in each operation you need to pick any value or any number from the array. You need to pick any number from the array, and once you pick it, you can modify it in this way, like either you can subtract anything uh, 0 to k, or even add anything between 0 to k, that you can do. And after doing these operations, we just need to return what is the maximum frequency possible after this conversion. So basically we should have a tendency in equalizing the numbers that are present. Suppose it is given 1, 4 and 5. So this was the example that was given, and k equals to 1 and n equals to 2, where n is number of operations. So what we can do, uh, so we can add 0 to this, right? So after first operation, it stays at 1 as we are adding 0, and in the next operation we can do anything, like maybe convert this to 5 or reduce this to 4. As k was 1, we can do that, it's permittable. So the answer for this is 2. The reason being that maximum frequency that we are able to achieve for a single number is 2. So the answer is 2. So how we can do this problem? So before discussing the solution, we should also look into the very important part, like what are the constants. So so number of elements, uh, which I'm denoting by n, is between 1 and 10 to the power 5, and the element itself can be again uh, can be again uh, in this range only, 10 to the power 5, and what, like we can add anything between, or subtract anything between 10 to the power 5. So this 10 to the power 5 actually suggests that we can do we can apply algorithms which lies in log, and maximum we can go up to this, so on this whole array. And as each of the element are within this range, we can also do maximum operation or in this range. Now if we think in that way, how we can solve it? So it's a bit tricky, because I will tell you why. So suppose you are given this, right? And what we need to do, and suppose k is given 2, and the number of operations it's also given 2. So what you can do is basically convert this 18 and 19 to 20. So your answer becomes 4, because you are able to convert all this element to 20. So the answer of this is 4. But if you notice, like if we have a window, like how I was initially thinking, like if we have a window of size k, and or sorry, if we have a window of size n, which is basically number of operation, and we will try to convert in this window, uh, basically we'll try to equalize elements in this window. So our maximum answer would lie between 0 to n, where n is the maximum number of operations. But it's not true, right? Because here we saw, like, even if we, like, as we are able to convert these two elements to 20, and we already have 20 over here, the frequency of 20 was already 2, so the real answer is 4. So how to solve this problem? Well, this problem, as it's suggested by the numbers, like the property of the numbers, like they can lie in the range of, so suppose any value can lie in the range of 10 to the power 5, right? So we can apply any operation between n log n. Let's think in binary search direction. So what we are going to do, we are going to basically search in the space between 1 and the maximum element that is present inside the array, or we can even search between minimum element that is uh, or you can search between the minimum element that is present in the array and between the maximum element. We will search this space. So the space can maximum uh, can be of maximum size of 10 to the power 5, right? And we can, like, if we do binary search in this space, each of this operation will take log n time, so we'll end up doing n log n, which is permittable, right? Because we can have in the search space maximum element as 10 to the power 5. So in each binary search, what we do in each binary search, we actually try to fit, or try to uh, convert the maximum element that we can convert into this search space. So first, suppose, so basically let's consider we have 1 to n. I'm just taking this range. So for any value, right, suppose we have this value as x, right? Now if you want to convert any value to x, what that value actually can be, it can be, as we are given that we can go up to k, it will be x minus k, right? And from the left hand side it's x minus k, and from the right hand side it's x plus k. So if we want to convert any value to x, it should lie in this region, x minus k to x plus k. So we will try to get what is the leftmost element for x minus k, right? And the leftmost element for x plus k, no, for x plus k plus 1. And we can and if we get a subtraction if of these two, we get the number of elements that can be converted. If we uh, take a subtraction of a binary search or bisect of these two values, we get how many elements that can be converted to x, right? Now again, so there is again a constant actually. So if suppose some of the elements in this range x minus k to x plus k are already x, do we really need to convert it? No, right? So we are going to subtract that. So whatever we'll get, we are going to subtract that, and As it is already converted, we are going to add that to the result. Now let's look at the code. It will be much more clear actually. So this is the code for it actually. As you can see, first we are sorting the number, and then we are counting or taking the count of each number that is present in this array, and then we are iterating over each possibilities. Basically we are trying to convert each element uh, to this target, and so suppose this is the target we are and this is the array. We have a1, a2, a3, an minus 1 and an, right? In this range we are in this array we are picking up a range which can be converted to target. So this is the range which can be converted to target, right? We got so this is the left and this is the right. We got the range. Sorry, this is the right actually. uh, yeah, so this will be the right, and once we take the difference we get the number of options that needs to be converted. Now if some of the elements are already converted, do we really need to convert it? No, right? As we don't need to convert it, we are subtracting it from it, subtracting it from like the number of conversions required, and after that we are taking minimum of this. Remember we have a constant on how many operations we can do, so we need to, so obviously we can't convert everything, we need to take minimum of this and count of target which is already uh, present in the target, like which is already counted. So once we have it, we can basically for each so in our search space we try to maximize the answer and return the answer at the end. So this is the question that was given. Now in the second or the third question what it was mentioned, so the question is the question was same only, but the constraint or the search space is increased from where each nums of I, so search space was increased from 10 to the power 5 to 10 to the power 9. Now can we apply this logic? No, right? Because if you want to do any operation of n log n, you can go maximum up to 10 to the power 5, but here it's 10 to the power 9, so we can't apply that logic. So how we can solve it? Well, uh, let me try to bring in the code. It will be much easier to explain what uh, so we have two things. So in the first choice what we're actually trying to do, we are actually choosing existing number. So whatever number we that is already present in num, right? We try to convert the other elements to whatever that is present. And in the second loop, what we're trying to do, even when the number is not present, like we create a midpoint of the left and right pointer and try to see if we can convert or basically we try to find out what's the maximum number of element that we can convert to that middle point of the left and right pointer, and we take maximum of this. So so first we have the left. So suppose again, suppose if we have this array an minus 1 an, right? And suppose this is am, we try to maximize left and right. So this is left, this is right, as far as we can go that we go, and once we have it, we have the total count that can be converted to the middle element, right? So this is our middle. Now what we do, we subtract the uh, count of middle element because that is already converted, so we don't need to convert it, and take the minimum of this count and the number of operations, because we are restricted with this number of operations, we cannot go beyond that. So we take minimum of this, and at the end we also add the count of middle because that is already converted. So this gives us the result if we try to convert to any existing element that is present. Now in this loop, what we do, we put the right pointer. So basically we have again left pointer and right pointer, and we keep on incrementing the right pointer. uh, so this is our array, right? We keep on incrementing the right pointer as far as you can go, so that left and right, basically the middle of this left and right maintains this condition. Basically the difference is k, the maximum we can go, that we go, and we try to maximize this answer. Once we have it, we return the answer. So as we see here, we are not searching the space of entire space of the range of number, but first, also what we are doing at first we are trying to convert the elements that are present uh, to the existing element in the number, in the array. And second, we are trying to uh, basically uh, create a middle element with left and right pointer, and convert the remaining element to that middle element, the maximum we can do, and at the end we are just returning the result. Now let's discuss the third question. Actually, it's pretty simple, reason being that it was the first one that I tried to solve. Like, so basically you are given two integers n and t. Return the greatest number equal to n such that the product of its digit is divisible by t. Now n was given 100, right? And it's an easy question, so we can apply brute force as it suggests. So this is the constant, so we can do whatever we want. I mean, like whatever optimal solution uh, we can do. So basically I applied extreme brute force logic here. So I'm inside a infinite while loop, and until or unless I meet this condition, I actually run that loop, and if I meet the condition, I just return it. So that is the solution of smallest divisible digit product 1. Now as you know, so that there was a one more question, which is smallest digit divisible digit product 2, that I didn't attempt. So these are the three questions that I attempted and I discussed over here. Thank you.